Hey everybody, we're just going to go over the lab analysis for experiment number 5, where we had to determine what compound we had. Did we have a carbonate or a hydrogen carbonate? So our four possible unknowns were sodium carbonate, potassium carbonate, sodium hydrogen carbonate, and potassium hydrogen carbonate. So the first step that we did to determine did we have a carbonate or a hydrogen carbonate is we heated up our sample. If we heated it up and we saw no reaction, meaning no decomposition, no loss of mass, then that tells us we would have a carbonate. Um, and then if we heated our sample and it turns out that our unknown was a hydrogen carbonate, then what we would see is a loss of mass because we would have the decomposition. Our hydrogen carbonate would turn into the carbonate version of that chemical. So sodium hydrogen carbonate would decompose into sodium carbonate. If I had potassium hydrogen carbonate, it would decompose into potassium carbonate. And then our other two products would be gases. So what we could probably do ahead of time is figure out, based on how much you started with, what would qualify as an appreciable amount of mass loss. It's possible that you had a carbonate sample and you had a loss of mass, but it might be only like 0.05 grams, which is probably just a little bit of water that the solid had absorbed over time. Okay, but that wouldn't be enough to qualify as a hydrogen carbonate. So let's say that we did have a hydrogen carbonate. These are the two reactions that would happen. The first step would be the hydrogen carbonate would turn into the carbonate, just using sodium hydrogen carbonate as an example. So that would be the first step. And then again, carbon dioxide and water would be gases that we lost in the environment. And then we added hydrochloric acid to our carbonate. And we'd make salt, carbon dioxide, and some water. And then the combination of any excess water that's left over from the acid that we added, plus any that we made, we boiled that off. And so in our crucible, the only thing that we would have left is our salt, our NaCl. So one useful thing to do that would maybe simplify this reaction is to try to combine these into one. And algebraically, you can do that using something called Hess's law. So what we're going to do is add up everything on the left-hand side of our reaction, the reactant side, and also on the product side, and see what we have. So I'm going to have 2 NaHCO3 plus Na2CO3 plus my 2HCl. By the way, sometimes our HCl is written as H plus and Cl minus. We'll probably do that later on in the year. I'm going to have my Na2CO3, my 2 CO2s, my 2 H2Os, because we've got 2 of them here, and then also my 2 NaCls. Now what you're going to notice as you do this is that you have sodium carbonate on both sides of the reaction. And so algebraically, these are going to cancel, just like if you had the same variable on both sides of an equation, you could cancel them out. So my overall reaction would then be 2 NaHCO3 plus 2 HCl, and then I'm going to have my 2 CO2s, my 2 H2Os, and then my 2 NaCls. Now, also what you probably notice at this point is that we have coefficients of 2 in front of all of these. And so then we could reduce our reaction to NaHCO3 plus HCl makes CO2, H2O, and NaCl. Now, the reason that's useful information is to say, well, what's the mole ratio and how they're reacting and based on what they're producing. So really what we have left over in our crucible is the salt. And the only other thing that we really know for sure exactly how much we added was which was the hydrogen carbonate that we started with. Again, assuming that it's the sodium version of it. So this would be the overall reaction if we had the sodium hydrogen carbonate. So let's run with that for the moment. And what we can then do is look at a mass relationship between the sodium hydrogen carbonate and the salt. So the mass relationship, if we had 1 mole of each, would be that if I had 1 mole of sodium hydrogen carbonate, it would have a mass of 84.01 grams. And the molar mass of NaCl is around 58.45 grams. Again, this is the molar mass. So if I completed my reaction as is, then using 1 mole of sodium hydrogen carbonate would equal 84 grams. 1 mole of NaCl, that means I would produce 58.45 grams. Now that isn't exactly what we started with, but what we have now is a mass relationship between these. So to turn this into something more reasonable, which you might start out with your lab, is that we could divide both sides by 84.01 grams. And if we do that, what we're saying is that if we had, for every 1 gram of NaHCO3, we would produce 0.696 grams of NaCl. And that's probably closer to what we would do in our lab, but basically what we have is a mass relationship between our substances. Now, if we had potassium hydrogen carbonate instead, we would be making potassium chloride. And so those would be the relationships that we would look at. So for instance, so this is the relationship if we had sodium hydrogen carbonate making this many grams of NaCl. We could then look at what if we had potassium hydrogen carbonate, and we can compare that to how much KCl we would make, because that's the salt that we would make. So these are reacting in a 1-to-1 ratio in terms of reacting and producing. If we look at our molar masses of KHCO3, molar mass would be about 100.11 grams. And if I used 1 mole of potassium hydrogen carbonate, that 100.11 grams, I would produce 74.55 grams of KCl. Now again, what we could do is that we could reduce that, and then so saying for every 1 gram of KHCO3, we would take 74.55 divided by 100.11, and that would tell us how many grams of KCl we would make for every 1 gram of potassium hydrogen carbonate. So 74.55 divided by 100.11, and we would get 0.745. And so what we can come up with is a mass relationship between these. Okay? So let me go and write that off to the side here, just kind of as a summary. So if we had sodium hydrogen carbonate, and we looked at the mass ratio to sodium chloride, for every 1 gram of sodium hydrogen carbonate, you would make, we said 0.696 grams of NaCl. If I had a potassium hydrogen carbonate, looking at how many grams of KCl I would make, it was for every 1 gram of potassium hydrogen carbonate, I would make 0.745 grams of KCl. So that's if we had a if we had a hydrogen carbonate. If we had just a carbonate, things would be a little bit different because of the mole ratio. So looking back at so if we had for instance, a sodium carbonate reacting with hydrochloric acid, we would make sodium chloride, still making the sodium salt, we're going to have 2 moles here plus our CO2 and our water. So we're looking at a 1 mole to 2 mole, 1 mole of sodium carbonate to a 2 mole of our salt ratio. So kind of following that same idea, if we had a sodium carbonate, we would, for every 1 mole of sodium carbonate, we would make 2 moles of NaCl. So the molar mass of sodium carbonate is 106.01 grams. So if I had 1 mole of that, that would be for every 2 moles of NaCl. And the molar mass of NaCl is about 58.45 grams. So what that tells us is, carrying this math out a little bit further, if I have, again, 106.01 grams, that's going to be in a ratio to 2 times our 58.45, which is going to be 116.9 grams. So if I had 106.1 grams of Na2CO3, I would make 116.9 grams of NaCl. And again, if we wanted to, we could reduce that. If you actually started and by dividing both sides by 106.01, we could reduce that to a smaller ratio. And so what that would say is, for every 1 gram of sodium carbonate, you would have 116.9 divided by 106.1, we would get 1.10 grams of NaCl. And if we follow the same logic, so then again looking at if we had a sodium carbonate and I wanted to know what would be the ratios, kind of simplifying it here. So for every 1 gram of sodium carbonate, given our mole ratio, we would make 1.10 grams of NaCl. If I did the same thing for potassium carbonate and looking at how many grams of potassium chloride I would make, we would follow that same idea. And so my ratio from potassium carbonate to 2 moles of potassium chloride, our molar mass of potassium carbonate is 138.2 grams for every 1 mole. Taking 2 times our mass of potassium chloride, 74.55, which is equal to 149.1 grams. Oops. Let me scooch that over here a little bit. So again, reducing this, dividing both sides by 138.2. We would say for every 1 gram of potassium carbonate, you would make 1.08 grams of potassium chloride. So this ratio reduces to, for every 1 gram of potassium carbonate, you would make 1.08 grams of potassium chloride. So keeping in mind those mole ratios, we could, and the data that we collected in our lab, we could use those to be able to figure out what substance we had. So if we had a appreciable loss of mass initially, we had one of these 2 hydrogen carbonates. And then looking at comparing how much you started with to compare to what you end up finding in lab, that could help you determine which of these salts that you made. Did you originally have sodium chloride, or excuse me, did you make sodium chloride or potassium chloride? If you had no loss of mass, you had one of these 2 carbonates. Now, as a side note to the mechanics of this lab and how you do your calculations and so forth, these masses that you would generate are really close to each other. So if you had a hydrogen carbonate, the product that you make, the masses that you would make are really close to each other. And also for the carbonates, the mass of product that you would make is very close to each other. So in this lab, what would be nice to do would be to have a secondary test to let you know which of these. So if you knew that you had a hydrogen carbonate to begin with, but your mass that you actually experimentally collected was kind of in between these, you could maybe do something like a flame test. So put a sample of that compound in a flame to be able to tell which of these salts it is, because the sodium will give like an orange flame, and then the potassium in a flame test will give you more like a pink or lilac color. So hopefully that adds some clarification about how to do your calculations in your lab and to determine which of these unknowns that you started with. Thanks for watching.